Hello, welcome back. Welcome to the course of Unix for testers, Unix manual concepts, and how we can automate all those Unix processes which we used in our day-to-day task as a part of testing, which can be integrated with any test automation framework. Let us say Selenium in this case because mostly I'm using Java in this case. Fine. So let us talk about Unix processes. Okay, so first let us try and understand what is process. Okay, so process, it's a general term. Okay, and in Unix terminology, a process is called as it is an instance of running a program. Whenever we execute any program, that particular instance of that program is called as a process, or we may call it as a program. A process is a program in execution. Okay, whenever we start execution of particular program, that triggers a process, or that is, let us say, that gets converted into a process. Let's take an example. If let us say three people are running the same program simultaneously, and then it will create a three different processes, because the same program is triggered by three different people, let us say three different users. So three different processes will get created, not just one, right? In fact, we might have more number of processes running even when only one person is executing a program, because one person may call another, sorry, one program may call another program, which may call another sub program, something like that. It's like splitting the programs. Okay, so like one process can get into a multiple processes. So basically process, whenever we run the program, it will get converted into a process. So that's what my process is. Okay, so uh, okay, so what processes can be, like how the processes will get triggered. Okay, so whenever I run any shell script, my processes will get triggered. Whenever I execute any command, my, in fact, programs. Okay, so because commands are nothing but programs, right? Programs in for Unix, programs are called as commands, right? Or it might be any daemon or any scripts. Okay, so whenever we trigger any of these things, your process will start. Okay, so let us take an example. If I go to my Unix box and give me a second. Okay, so if I do something like this, pwd, give me a second. Okay, so if I do kind of pwd, that is my print working directory, it is giving me some output. Okay, so I'm hitting one command. So internally what is happening is, this command is nothing but a program for Unix. So this command will trigger a program, that program will trigger a process, right? So ultimately my command will trigger a process. So likewise, whenever I execute any shell script, it will trigger a process. Okay, so that's what your process can be triggered with shell scripts or commands. Okay, so next is, what is the parent of all processes? Okay, so basically when we boot up my Unix machine, okay, so what happens is, it initialize all the things, like what hardwares I'm using, what softwares I'm using, like it initializes all the things, right? And all, so for initializing all those things, we need a script. Okay, so basically there is one process called as init. Okay, so if I go to my, let us say, WinSAP, this time I'll go to WinSAP. I'm browsing the same Unix server basically. So if I go to my root folder, and if I go to etc, and in etc folder, if I go to apt, so here I find some scripts. Okay, some scripts. So basically all these scripts get triggered automatically whenever my Unix system boots up. Okay, and basically that's the function of init process. Okay, init process, initialization process. Okay, uh fine. And so basically init is the parent process for all. It is a parent of all processes, init process. And there is something similar, another process which is again mostly used during boot up time itself, which is jetty command, getty, okay, which takes care of your logins of different users or different sessions. It takes care of all those things. So basically init is your uh, what I can say, parent of all the processes. Fine. What next? Okay, so before I move to the types of processes, let us understand little more about commands. Okay, so whenever any command is issued to a Linux or any Unix OS, basically it creates or starts a new process. For example, as I have shown you, whenever we issued a command pwd, it creates a process for you. Okay, and whenever the process is created or a process is started, each process in Unix or Linux have a 5-digit ID called as process ID or PID. Okay, and that 5-digit ID will be unique in your uh, Unix operating system. Okay, and it ranges around 1 to 30,000 or 0 to 30,000 in fact. Okay, okay, and since it is a unique, as I said, it is a unique process ID. It will not be same for multiple processes. Each process will be having the unique uh, process ID. Okay, so if I go to, okay, I'll talk about commands later on little bit. Okay, but to get the list of processes, we have a command called ps, and here you see something called as PID, which is my process ID. So you can see I have two processes running over here. It has, and two processes have different process IDs. So basically these are your process IDs. Okay, and it ranges from 0 to 30,000. Okay, and it is unique for all the processes. Now let us start talking about your types of processes. So as I have mentioned here, we have two types of processes: foregone process and a background process. So from the name itself, we can understand foregone process. Every process, when it is started run, it by default it starts its running in foregone. Okay, so it's like whenever I hit any command, like as I done over here pwd, my command is starting in foreground. That is, I can in fact it is a user interactive, like I can enter the input, or I can see the output. So basically it is foreground, which I can see. Okay, so the basic disadvantage of foregone process is when a command or a process is running in foreground and it is taking a lot of time, no other processes can be run or started because the prompt would not be available until the program finishes processing and comes out, right? Because see, this I typed pwd, it has given me instant result, but there might be some program, when I start those particular program, it might take some minutes to execute, some hours to execute. Okay, and while those programs are executing, I may not be able to do any other things. Okay, let us take an example. Okay, in my this particular directory I have some shell script. Okay, yeah, I have this shell script, and I'll tell you later on in detail like how we can execute shell script and all that. We need not to worry, just I'm running it over here with command sh script dot sh. I'll demonstrate about creating script, executing script in our later videos. That's perfectly fine. So as I said, when process will get triggered, whenever we fire any command, any program or any script, my process will get triggered. Okay, so before I run this shell script, you can see we have only two processes. That's fine. Now I am going to trigger this particular process. Fine. And here you can see my it has printed something that is a part of my shell script, and I do not see anything to enter or input over here, or I do not see any output because my shell script is running. It is running. Okay, and in fact I have just entered some sleep time over there, but it is running, let us say, right? So in this particular time I'm not able to use this particular terminal, right? So that's what the basic disadvantage of running your process in foreground, that I am not able to utilize this particular terminal until and unless this particular process is terminated. That is your foreground process. Fine. Now I am going to terminate this process with Control C. I have terminated my process, and if I check the list of processes, again I have two processes because this particular process is turned off. Fine. Now there is something called as a background process. Okay, so as the name suggests, background, so the process is running in background. So it runs in the background without keyboard input and waits till the keyboard input is required. Thus other processes can be done in parallel with the process running in background, since they do not have to wait for the previous processes to be completed. Like I said, okay, so what I'll do is I'll enter the same shell script. Okay, let me clear this command terminal. Okay, now what I'll do is I'll run the same script. Okay, sh.script.sh. I'll run this shell script, but this time I'll run it in background process. And how we run any command or any script in background, just we need to give ampersand after your command or script. That's how your Unix terminal will understand that whether he needs to run that particular command or script in foreground or background. If you see anything ampersand, Unix will run it in background. I'll hit enter, and you can see it gives you the process ID 24399. So my process is running now. Give me a second. What has happened? We gave ampersand. Fine, my process is running. Great. Now if I check for PS, that is processes, you can see like earlier there were only two processes, bash and PS, right? But this time I see these two processes got added and these two processes are running. Okay, even though these processes are running, I'm able to run my further processes, right? Because this particular script I have triggered is in backend, right? Background, it is running it in background. So you can see the processes are still running. Okay, so this is basically the difference in between foreground process and background process. Okay, so what else? Okay, so what next we have? Okay, so moving the process from background to foreground and vice versa. So we have two commands like bg for background on fg for foreground. So we can use this command to switch your background command to foreground and foreground to background. Basically I was talking about processes. Okay, so you need to give bg followed by process id, which you can see over here. This is my process ids, pids. It will convert your process from one bg to fg or fg to bg, whatever you want to do. Okay, so we can do that. Okay, what next I have? Okay, some important commands related to processes. Okay, so I have shown you how we can use ps to see the processes status. So I have shown you we can use ps to get the processes status. So you can see here I have 4 different processes running. Fine. Okay, and if you want little more detail, you can use ps-f. Okay, so you can get little more details like uid, what is the user, so Prakash is my user. PID, what is your process ID, so these are the process IDs for different processes. Then you can see something called as PPID, which is parent process ID. Okay, so parent process ID, and here CPU utilization, start time, terminal type, time, and command. Okay, so here you can notice something. This is my PID, process ID, and this is my PPID, that is parent process ID. Now observe middle two things. Okay, these two things. Here process ID 24399 of this script.sh is the parent process ID for your slip process, right? So what this means is, initially I triggered this particular script. It has triggered basically a process, and then this process has triggered a child process. So that's the reason this is a parent process ID for this particular process. So by using this process ID, this particular process has got triggered. Okay, so that's the basically the concept of your parent process and a child process. So parent process, let us say it is a base process, and let us say in your from your parent process, if there are some chances like there is something like multiple processes may get triggered. So those multiple processes which got triggered from your one base process are called as your child process, and your base process is your parent process. So you can see them by using this particular IDs: parent ID and process ID, process ID and parent process ID. Okay, and even if I show you the script, okay, the script is nothing, it is just uh, one line. Give me a second, let me show you that script what I'm doing. So in that particular script, what I'm trying to do is I'm basically so you can see here this is my script.sh. I have triggered this script.sh. Okay, and from that script.sh it has triggered this slip process, right? So this script.sh is my parent process, whereas this slip and this whatever time duration is my child processes. Okay, so this is what your parent processes and child processes are. Okay, now what else we have? So there are a couple of more options be used with option PS, process status. Like we saw PS to get the list of your processes, then we can use PS-F to get them in detail. Then we have something called as PS-E to get all the processes, list of all the processes, which in fact I have not triggered, my OS has triggered. And we have, if let us say if you want to get the processes which are triggered by your user, so I have typed PS-U and my UID, which is Prakash. So it will give me the list of all the processes which are triggered by my ID. Where it is? Yeah, so from here these are the processes which are triggered by my UID. What else? Okay, and one more is there for hierarchical view. Okay, if you want to see the tree like structure, so we have some command like ps hyphen uppercase h. So if there are some scripts or programs which are calling some sub programs or sub processes, like in this case you can observe this middle two rows. Okay, so in this you can see one some tree like structure, though it is very small. The sh is triggering slip, that is the slip process it triggered by sh. So this is a kind of tree like structure. If you have again a little sub processes, you can find it in a tree format. So that's what basically this ps hyphen h is. It gives the tree like structure. So from here till now you must have clear this 24399 process id, that is command sh, is my parent process id, and the next one is my child process id. Okay, what else? Okay, so this parent and child processes we already talked. Okay, and okay, and if you have any processes, let us say sh, and this time I'll run the script in foreground. Okay, so my script is sh and my script execution is started now, so I'm not able to do anything. But for some reason, if I want to terminate my process, to stop my process, then we have some interrupt character which is control C. So if I hit control C now, my process will get stopped. Okay, so that's how we can stop the process basically if it is running in foreground. But what if my process is running in background? Even if I do control C over here, my process is not getting stopped. See, if I do ps, my one of my process, couple of my processes are running, right? But since they are running in background, even if I use control C, I'm not able to stop them, I'm not able to terminate them. So to do that, we have some command called as kill followed by process id. So I'll give the process id as 24399. Okay, so what this means is I want to kill this particular process id, which is my sh script. Okay, I'll hit enter, and if I do ps-f now, you can see that particular process is not still in my list. So now I have only one process in my list, which was my child process. Now let us try and understand what has happened. The process, which is this particular sh process, initially I triggered this sh process, and from this sh process this child process has got triggered. Okay, so in the program flow, you must be understanding, okay, if my base program is calling some sub program, a child program, basically my base program is waiting for some response, some signal from the child program, right? Now in this case, since my base program or base process itself is killed, where my child program or where my child process will send response to, my child process will not be able to send response to anyone because its parent has died, right? So this kind of processes are called as orphan processes. Okay, orphan processes. So okay, and there is something called as zombie processes. So what are zombie processes? So let us take an example. I have already killed the process, but still that process is getting reflected in my when I do PS. Okay, when I do this PS command, if my process ID is still showing, but I have already killed it, but it is not getting reflected. So such a kind of processes are called as zombie processes. They are dead and they are of no use, but still my processes I can see them in my processes. So that was pretty much about the Unix processes. So we talked about what is processes. Whenever we start execution of any process, any program or any shell script, basically it turns into a process. So we have two types of process. In fact, parent of all processes is my init. Then we saw something called a jetty, which is responsible for login mechanism. Then we have foregone process and background process. So whenever we hit any command on your terminal, by default it will start in foregone process. In background process, we need to use ampersand. We can move the processes basically from background to foreground and vice versa. Then we saw some different commands, in fact ps only, with the various options, and we talked about what are the parent processes, child processes, and basically this zombie process and orphan process. So that's it about this Unix processes. Stay tuned. Thank you.